Three interviewers ABC are interviewing 40 applicants. Only with the three interviewers admission can an applicant be admitted. If interviewer A admitted 15, 17 and C 20 candidates. Now, this I am going to solve with a slightly less frequently used method. Let's assume that we have 40 candidates and those 40 applicants are being represented by this particular line. Now, A admitted 15 applicants. So, A admitted 15 applicants. So, for those 15 applicants, I'm just drawing a line like this. So, these are the first 15 candidates that A qualifies, right? Then the question says that B qualifies 17 candidates. Then I am quickly drawing another line for 17 candidates of B, and C qualifies 20 candidates. That means for C I can again draw a line which is as big, and this is C equal to 20. So you understand the possibility is that A is intersecting C, B is intersecting C, but A is not intersecting B at all, and therefore we don't have a candidate who has ascent of A and B both. And in that case we can prove that the answer to the question, that means the people who get ascent, the admission of all the three interviewers, is 0. That means common to all these sets minimum can be equal to 0. Therefore the answer to the question becomes option A. Thank you so much. Three interviewers ABC are interviewing 40 applicants. Only with the three interviewers admissions can an applicant be admitted. So when all three interviewers say yes, only then the applicant can be admitted. If interviewer A admitted 15 applicants and B admitted 17 applicants and C admitted 20 applicants, then we are actually looking for the possibility in which we can find out the common to all the three circles, right? So we have the first circle here, we have the second circle here, we have the third circle here, and these three circles are for the people who have been admitted by these three interviewers. Now if we start filling them in, what we see is that total candidates is 40. A is qualifying 15 applicants, B is qualifying 17 applicants, C is qualifying 20 applicants. Now we have to find out the minimum possible value of X here. Now, but the interesting thing is that this will be minimum only when there is necessary intersection. But what we see is that between this 15 and 17, there is a possibility that the intersection is 0, because 15 plus 17 is still 32, which is less than 40. So there is definitely a possibility that the intersection is 0 and the remaining 40 is getting balanced with these 6 places, right? These 5 places actually. So there is this possibility that X can be 0 here. That's precisely because 15 and 17, if you take the intersection, their sum is less than 40. Same thing goes 15 and 20, the sum is 35. That means we could also look for the possibility where there is no intersection between A and C. So there are various ways in which we can prove that X minimum can be 0. Now, just in order to make sure that you understand that this is a possible thing, let me just quickly make a distribution, one possible distribution maybe. So I'm just taking a random number, not anything specific, maybe that out of this 15, let us say 10 comes here, so 5 comes here, right? This entire circle has to be 20. Now I'm saying that these three regions are A, B, C. So A plus B plus C must be equal to 25, and we know that A plus B is equal to the remaining 10, which means C becomes equal to 15. So now that C is 15, I know B should be 17 minus 15, that is 2, and A should be equal to, because A plus B is 10, so A becomes 8. Now if you see, it satisfies the condition. That means the summation is equal to 40 while X minimum can be 0. So this way we have been able to prove it, but it's only to satisfy the curiosity of the candidates. You should understand that since there is a possibility that there is no intersection, and therefore we just try to realize that possibility by putting certain numbers here. I hope you enjoyed the explanation. Thank you so much.